These are your 1-6 notes, compound inequalities. So we're going to take the concept that we learned with inequalities, but we're going to actually solve two inequalities at the same time. So that's the whole definition of compound. If you think about a compound sentence, it's two simple sentences or simple statements connected with an and or an or. And in the English language, whether you use and or you use or makes a big difference. And so in math, it's the same way. So we'll talk a little bit more about that tomorrow when we're in class. But in an and compound inequality, both inequalities must be true. So the solutions must work for both. I only want numbers that make both statements true. So if you look at this example, it says x has to be greater than or equal to -1, and x has to be less than 2. There are a lot of numbers that are greater than -1, but that are not less than 2. So in this particular case, because we use the word and is only true if you satisfy both inequalities. So if you were to look at these two inequalities on a number line, if I did it separately first, I'm just going to show you separately. Here's -1. And on the number line here would be +2. So the first inequality is asking for values that are greater than or equal to -1. So that would include -1 and all the values to the right of -1. And in the second value, x less than 2, is talking about all the values lower than 2, not including 2. So that would be all of these numbers here in the blue. So you can see that those arrows are not necessarily going the same way, that all of the red solutions are not all of the blue solutions. But if I was to take those two number lines and put them together, squish them together into one number line, you would see that the numbers between -1 and 2 would overlap. And so if I put them on the same number line, the solutions where there would be overlap is right in the middle there. So you would have a closed circle at -1 and to the right, an open circle at +2 and to the left, and where the two values overlapped is in between. Now my values did not bleed through, but red and blue make purple. So I'm going to show the overlap in purple here. And so you can see that those would be the solutions. So the solutions to this compound inequality are the numbers between -1 and +2. So how we would write that as an interval notation, probably the easiest way, -1 all the way to 2, all the fractions and decimals and whole numbers in between. 0 is greater than -1 and it's less than 2. 1 is greater than -1 and less than 2. And 1.5, 1.6 is still greater than -1 and less than 2 at the same time. This would be a bracket parenthesis for interval. Set builder is a little bit different since the numbers are between. When we write our solution, we're going to describe x as our solution such that we're actually going to put x in the middle because the solutions are in the middle. I'm going to put my -1 here, my +2 here, and if I keep with my symbols both pointing to the left, it makes sense. It's a little bit more difficult, but let me explain that. The solutions are in the middle, in between -1 and +2. Even though it looks like two less than symbols, when you read it from the variable x, it's reading x is greater than or equal to -1 when you read it that direction. X greater than or equal to -1 and x less than 2. So it's between. So a little bit difficult, but I want you guys to practice that. So I get the number line. The number line helped me get the answers. It's where there's the overlap. So when we talk about the solutions to an and compound inequality, we're talking about the overlap of the two solutions. Now, or is different. Or is a little more forgiving. It's one or the other, or technically it could be both. So there could be overlap, but it's not as picky. You just have to satisfy one or the other, or if both is true, that's fine too. So you're looking for values that satisfy one of the inequalities or the other inequality, or technically you could satisfy both. There doesn't have to be the overlap here. So if I show you this one, x less than or equal to 1, and then the second one separately would be x greater than 4, and then I'll show them combined on the same number line. So when we graph an OR compound, we could be talking about the values less than or equal to 1, so that would be 1 and to the left, all those numbers. X greater than 4 are all of these numbers. Open circle at 4, we're not going to include 4, and everything to the right. When I put them on the same number line, there is no overlap, and that's okay. So basically, we can use the red numbers, or the solution could be in the blue section. The only numbers that don't work are where there's nothing. So like 2 is not less than 1, and 2 is not greater than 4. So the numbers between 1 and 4 do not work. So to write this, set builder is a little bit easier to write these solutions. These solutions would be x such that, and you describe each number set. This number set is when x is less than or equal to 1, or this number set when x is greater than 4. You basically just put both solutions in there, you use the word or, and that implies that they're not overlapping. In interval, you would actually have to write two different intervals. You'd have to have an interval for 1, so those are the values from negative infinity to 1, including 1. And then you have to write another interval 4 to positive infinity. So not my favorite type, but I want you to get in the habit of that. I think that interval notation is better for and compounds, and the set builder is better for ors. All right, so let's go ahead and try these. So I have an example of each type. First, we're going to start with the or, and then we'll get into the and. So an or compound inequality, these aren't solved for, so we're going to solve them first, and then we'll put them on a number line and go through the steps. So I'm going to add 3 to both sides here to solve this inequality, y greater than 4. And on the other side, the other compound or the other inequality, subtract 2. Y is less than or equal to negative 1. So I'm going to put both of those on a number line. And as long as you put them in the right order, so negative 1 goes first, then 4. And when I put them on the number line, y greater than 4 is going to be an open circle at 4 and to the right. And y less than or equal to negative 1, I'm just going to circle in green so you know that's what that is going to be closed at negative 1 and to the left. Those are the numbers less than negative 1. The fact that they don't overlap is okay because we're dealing with an or. So the or is everything. And so our solution, this is a picture of our solution. Now we need to interpret it. So my solution is x such that, I'm going to describe this part, x is less than or equal to negative 1, or, now I'm going to describe this section, x is greater than positive 4. For the interval notation, to describe the values less than negative 1, that interval would be from negative infinity to negative 1, parenthesis, bracket, and from 4 to positive infinity, double parentheses. And there you have it. I want to go back to the other slide really quick, and I just want to say, just like we said for and, it's the overlap. For or, it's everything. You do not exclude You include everything, okay? Everything that's been shaded. So in this example, we included everything. The only numbers we did not include were the numbers between -1 and 4. All right, here's an and inequality. So I want to mention that this is an and. When you don't see the word and the variable is between, that means it's an and. And so it's a little difficult sometimes. So what you do is you have two together. I'm going to separate them for you. The easiest one is the second one. So I'm going to rewrite this inequality, and I'm going to ignore the first inequality and the first number. So this one's pretty simple to write. D plus 5 is less than 8. So that's really the second inequality that they have there. The first inequality is kind of backwards. So it's still the D plus 5. Now I'm going to rewrite that though so that the D plus 5, I like my variable on the left-hand side. So I'm going to say D plus 5 on the left-hand side. I'm going to put the 3 on the right-hand side. But by flipping the inequality, I don't want to change the value of the inequality. So in the way that it's written, the inequality is pointing at the 3. I still want the inequality to point at the 3. I still want D plus 5 to be greater than 3. So by trying to maintain the value, you have to flip the inequality. So you have to change it to keep it, if that makes sense. All right, let's go ahead and solve. So we're going to subtract 5 from both sides. D greater than -2 is my first inequality solutions. And then on the other side, I'm going to subtract 5. D less than 3 over here. So keep track of any questions. If there's any misunderstandings, you can always put a little star by it or write a little question next to it, and I'd be happy to answer those questions tomorrow. So to put this on a number line, I just want to make sure that my numbers are in the right order. So -2 is going to go to the left of +3. And when I graph them, D greater than -2 is open at -2 and to the right. D less than 3 is going to be open and to the left. And the values where they overlap are between -2 and 3. We can't include -2 and we can't include 3 because they won't work for both. They won't work for both. So when I write my solutions, I will write them as, for the interval, my interval of solutions goes from -2 all the way to +3, not including either of them. So it's a range of values between -2 and +3. And then my set builder is x, such that I'm going to put the variable in the middle, put my numbers in order from least to greatest, and then point at the smaller numbers. And there you have it. X is between -2 and +3. It's greater than -2, but it's less than +3. All right, so the next part here, we're going to save this for a warm-up tomorrow. So don't do anything to that. I'll have you guys work on that tomorrow in class. We'll go over it. And so your lesson summary is I want you to explain the difference between the and the or. What does it mean? What is the difference when you change that one word? How does that change your answers and solutions to an inequality? And then I need you to solve this or compound inequality. So when you solve it, I want a number line, and then I will let you choose whether or not you want to use interval or if you want to use set builder notation. Good luck.